Okay, so I am gonna discuss another problem from TIFR 2022. Okay, so the problem states that a particle of mass m in three-dimensional potential well has a Hamiltonian of the form this. So you have a three-dimensional potential well and particle of mass m, where omega is a constant. Now, if there are two identical spin half particles in this potential having a total energy of E is equal to 6 cut omega, then the entropy of the system. Okay, so pause the video and give this problem a try by yourself and then look at the solution. So the problem statement is not much complicated, but you have to keep some things in mind. First, the potential, then what will be the energy levels. Then you have to set your energy level such that this your total energy will be 6 cut omega, and there are spin half particles. So these three are the key points from this problem. Okay. So first thing, let's try to write down the potential. So maybe all of you know this techniques actually. So let me write it once again. Plus 2m omega squared joule square. So you can write this as 1 by 2m 2 omega whole square into z square. So your Z frequency, your in the Z axis it will be the 2 omega, and for Y and X it will be omega and omega. So the quantum number for your energy levels will be for X axis it will be nx plus half h cross omega, and it is not a isotropic harmonic oscillator; it's an anisotropic harmonic oscillator. So you have to take things separately. Okay. So ny plus half h cross omega plus nz plus half into this is 2h cross omega because it is 2 omega. So just put all the things together, nx plus ny plus 2nz plus half plus half 1, and there is 2 into half 1, 1 plus 1 is equal to 2, that is h cross omega. So this will be your energy level and dependence on the quantum number. Okay, so now you have to make a total of 6 h cut omega. Okay, and you have two particles, so each particle should have energy maybe 3h cross omega, 3h cross omega. This will be a possibility. Maybe 1 plus 5 is also 6. This is also a possibility. Okay, 2 plus 4 is also a 6, so this will also be a possibility. 3 plus 3 is 6, this is already a possibility. So there are many kinds of possibility that can be happen. So we have to write the energy levels, first few energy levels at least, to get a feel that how should you distribute the particles, that your total energy should be 6 h plus omega. Okay, so the ground level, let's say, so for ground level just put all the nx, ny and nz as 0, so all the quantum numbers is 0. So your ground level will be 2h cross omega. This is 0 0 0. Okay, now you have to go to second excited level, the first excited level, the second level. No, the first level, the ground level is 2, so the next level can be 3. Now how can you make 3? Okay, so if you put nz is equal to 1, then it will be 2 plus 2 already 4, so it will be greater than 4. So nz cannot be 1, nz should be 0 to make a total of 3. But your nx and ny can be different. So it can be 1 0 0. That means 2 plus 1 plus 0 plus 0, it is 3. And it can be also 0 0 1. Okay, sorry, 0 1 0 0 1 0. Nz should be 0. Nz should be 0 to make a total of 3. Okay, but nx and ny can exchange between 1 and 0. Okay, so then your total energy will be 3h cross omega. So your 1 0 0 total energy is 3h cross omega, and for this case also it will be 0 1 0, and still it will be 3h cross omega. Now after 3 you can obviously think about 4. The first is 2, second is 3, the third one obviously will be 4. Now how can you make a 4? So set nx is equal to 2, second one will be 0, second one will be 0, so 2 plus 2 is equal to 4. It is already, it is a possibility. 0 to 0 a possibility, 1 1 0 a possibility, 0 0 1 also a possibility, because nz has already a 2 multiplied behind, so 2 into 1 is 2 plus 2 is 4. So these are 4 possibilities. You can think other possibilities also maybe happen, but I can see that these are all only the 4 possibilities. Okay, so write it here. So you have to basically think like this approach, that how can you make 2 3 4 for this kind of non-isotropic harmonic oscillators. Okay, so 2 0 0 is 4, 0 2 0 it will be 4, 1 1 0 is also will be 4, and 0 0 1 also will be 4, because nz is already multiplied by a 2. Okay, so it is 4h cross omega. Okay. Now the next thing, whatever may be the energy levels, how many degeneracies are there, doesn't care about, but it will be 5h plus omega for sure, because 300 is already a possibility, 030, and there can be other ones also. 210, 120, maybe other, don't doesn't care, because if if you already put a particle in 5h cross omega, say you put a particle in 5h cross omega, then the remaining particle should be in a state h cross omega to make the total of 6. So you have already put a 5 here, so the next one should be in 1 h cross omega, because 5 plus 1 is equal to 6, but there is no states available that has a energy h cross omega. Okay, so there is no possibility that 5h in 5h cross omega you should put a particle. You shouldn't put a particle in 5h cross omega state to make the total 6. It is not a possibility for this question. So you shouldn't care about that what is happening to 5h cross omega. So the only interest to you, this is 2, 3 and 4. Okay. So let us write this 2, 3 and 4 once again. So it is 0, 0, 0, 2h cross omega, 1 0 0 0 1 0, 1 0 0 0 1 0, that is 3h cross omega, and 2 0 0 0 2 0 1 1 0, 2 0 0 0 2 0 1 1 0 0 0 1. These are all 4h cross omega. Now, how can you make 6h cross omega from two particles? The obvious thing is that both the particles are in these states. Yeah. So this will be a 3h cross omega. So first think about this state. So there will be two degeneracy, 1 0 0 and 0 1 0. Okay. So these are the two cases. Now how can you put two particles here? They are spin up particles. So let's put, this is a configuration. This is a possible configuration. Okay, and they are 3h cross omega. Okay, so 3h cross omega, put two particles, so 2 into 3 6h cross omega. Okay, what will be the another possibility? What will be the another possibility? Just put two particles here, this will also be a possibility. What will be the another possibility? Another possibility is put one here and one here. Okay, so in these three ways, one two three, three ways, you can make 6h cross omega. Okay, complete. Now think about 2 and 4. So here you have an energy level of 2h cross omega. Here you have 4 levels that have same energy, 4h cross omega. So how can you mix 6? Just put here 1, and from this 4 you can put it here, you can put it here, you can put it here, you can put it here. Doesn't matter. For this case it is 4 plus 2 6. For this configuration, I mean for this configuration it is 4 plus 2 6. 4 plus 2 6. For this configuration also it is 4 plus 2 6. For this configuration it is also 4 plus 2 6. So any of these four states will do the job. Okay, so you can put the second particle in this any of the four states. Total possibility is 4. So from this case you will get 3, from this case you will get 4. So 4 plus 3 is 7. But remember, I am doing this for like identical particles and they are like bosonic particles. I am putting this that small circle for each of them. Okay, but they are up down configuration. Okay, so the up down configuration is not is equal to down up configuration. So there will be extra factor of 2 because of the spin half particles, because the up down configuration is not same as the down up configuration. They are different. Okay, so you have to multiply the extra factor of 2. So your number of possibilities, number of ways you can make total a 6 cross omega is 7 into 2 is equal to 14. So what is your entropy is equal to k log 5 is equal to k log 14. So for this kind of harmonic oscillator problem, there is not a isotropic harmonic oscillator. It's a non-isotropic harmonic oscillator. There is no general formula. Okay, you have to do do with basic countings. You have to think that how can you make the total energy levels this, what should be your quantum numbers in x, in y, and in z, that you can make the total energy 6 cross omega, or maybe it is 8 cross omega given in the question. Whatever be the in a total energy eigenvalue, you have to just think basics and do the basic counting to do this kind of think this kind of this way, that how can you fix the quantum numbers in x and y in z so that you can make a total energy given in the question. Okay, so there is no general formula or procedure. You have to rely on your basic thinking techniques. Okay, so yeah, this is a good problem from TIFR 2022, and that's it for today. Thank you.